Hello everyone, this is video 8 in the college algebra series, and today I'll be talking about parallel and perpendicular lines. So here in the figure we have parallel lines on the left and perpendicular lines on the right. As you can see, parallel lines never meet and perpendicular lines intersect once, and the angle at which they intersect is a right angle, so you have the angle is 90 degrees. So once again, parallel lines never meet and perpendicular lines intersect at one point, and they intersect at the angle of 90 degrees. So how are the slopes related? So you can see here parallel lines have same slope. So here we have two lines and we see that both the m of both lines here, both the green one and the purple one here, is 2/9. Whereas when you have the perpendicular lines, they are the negative reciprocals. So what this exactly means is here you can see says m is 4/1 and it is positive. So the reciprocal essentially is flipping the denominator with the numerator. So here you, instead of having 4/1, you would have 1/4, and then you flip the signs as well. So because m was a positive, m will now be negative for the perpendicular line. Again, parallel lines have the same slope, perpendicular lines have negative reciprocals. So let us do a few problems and practice a little bit and see how we can find out if two lines are perpendicular or parallel, and if we are given one line, can we find another line which is either perpendicular or parallel? Okay, so first question here is determine if the lines are parallel, perpendicular, or neither. So here we are given two equations, right? And we are asked to find if these two lines are parallel, perpendicular, or neither. So once again, if they are parallel, the slopes have to be the same. Slopes have to be equal. And if they're perpendicular, the slopes have to be negative reciprocals. Okay, so let us find slope for both the points. As you know, y equals mx plus b is our line equation, which is in the slope-intercept form, and here m is our slope. So let us write both the equations in this format. That would make it easier for us to find out what m is. In the first equation here, we are already given it in a slope-intercept form, so we know that our m is 2. So m is 2 for this equation, and for the next equation we can write it in the slope-intercept form. That would be 2y equals negative x plus 7. I get this by subtracting x on both sides. Then y equals negative 1 over 2x plus 7/2. I get this by dividing 2 on both sides. And here you can see that this is in our slope-intercept form. And we can see here that negative 1/2 is the m. So clearly both the m's are not same. So we know that it is not parallel. So is it perpendicular? Are these two lines perpendicular to each other? We see that yes, they are perpendicular to each other because m here is 2, and the reciprocal of this would be 1/2, and the negative of it is going to be minus 1/2, and you see that the slope of the second equation here is the same. It is negative 1/2, which makes these two lines perpendicular. So these two lines are perpendicular to each other. Okay, let us do another problem. Again, we want to determine if the lines are parallel, perpendicular, or neither. Let me copy this down. Okay. Again, we know parallel lines, that means slopes have to be equal, and perpendicular lines, slope have to be the negative reciprocals. Again, we have our slope-intercept form as y equals mx plus b, where m is the slope. So let us write down our first equation in the slope-intercept form. That would be 3y equals negative 2x plus 7, and y equals negative 2 by 3x plus 7 by 3. So here we have our m as negative 2 by 3. Now let us find the slope-intercept form of the other equation here. This would be 6y equals negative 4x plus 2. Y is negative 4 by 6x plus 2 by 6. Y equals negative 2 by 3x plus 2 by 6, or I could say 1 by 3. Here we have our m, which is negative 2 by 3. As you see here, we have the same m for both the equations, that is, we have the same slope, which makes them parallel. So since they have the same slope, they are parallel lines. One thing to note is parallel lines, though have the same slope, their intercepts have to be different. As you can see in this figure here, the y-intercept for the purple line is here, whereas the x-intercept is whereas the y-intercept for the green line is here. Though they have the same slopes, they have different y-intercepts. But if you think of this as two lines having the same slope and the same y-intercept, that would mean that they are the same line. So it could be the same line, right, one on top of each other, which are not parallel lines. It would just be the same line because they're meeting at infinite number of points, and parallel lines never meet. So that is one thing to be very careful about, because sometimes you could have problems that would, like for example, you could have a problem which is you have 2x plus 3y equals 7 and 4x plus 6y equals 14. So here you see that one equation is just twice of the other, and if we find the slope of this equation, as you see here, we got slope as m equals negative 2 by 3. And let me try to solve for the slope for the second equation here. That would be 6y equals negative 4x plus 14, and y equals negative 4 by 6x plus 14 by 6, which would give us negative 2 by 3x plus 7 by 3. So what would you think? You just see that the m's are the same, and we would automatically assume that they are parallel lines. But if you look closely, we see that their y-intercepts are the same. We have 7 by 3 and 7 by 3, which means that they are not parallel lines. So this is one thing to be really careful about, is making sure the y-intercepts are different, because parallel lines have the same slope and different y-intercepts, and perpendicular lines, they meet at one point and one point only, and they meet each other at a 90-degree angle. So their slopes are negative reciprocals of each other. All right. Let us do another example here. So we want to find the equation of the line that passes through 2, 5 and is parallel to the line 2x plus y equals 6. So again, because now here we are talking about parallel lines have the same slope. So let us first find the slope. that would be 2x plus y equals 6. We want it to look something like y equals mx plus b. Then m is our slope. So that would be y equals negative 2x plus 6. So here we have slope as negative 2. So m here is negative 2. And this is our slope. Now once we know our slope and we have a point, we can use either the slope-intercept form, or the point-slope form to find our equation. Both would give you the same answer. I will use the point-slope form, which is y2 minus y1 equals m times x2 minus x1. And let me assume y2 as y and x2 as x. And we have 2 as our x1 and phi as our y1. So we have y minus y1, which is phi. M we found is negative 2 and x1 is 2. You get y minus phi equals negative 2x plus 4, and y was negative 2x plus 4 plus phi, giving us y equals negative 2x plus 9. So this is the equation of the line that passes through 2, phi and is parallel to the line 2x plus y equals 6. So again, how do we verify this? First thing, we see that both the m's are the same. When you look closely here, we have the same m's, which is negative 2. Their y-intercepts are different, making them parallel. And the last thing is to check if 2, phi is actually a point on this line. How would you do that? Just plug in 2 and 5 as x and y values. So here we have y as 5, so 5 equals negative 2 times x, which is 2, plus 9. So you get 5 equals negative 4 plus 9, giving us phi equals 5, which is a true statement, which tells us that this equation here is both parallel to this line and it passes through 2, 5. All right. One last problem here. We have find the equation of the line passing through 6, negative 4 and is perpendicular to this line, which is 3x plus 7y. 3x equals 7y plus 5. So first thing is two lines are perpendicular when their slopes are negative reciprocals of each other. Yep. Okay, so that means first step, find the slope. That would be, we want our equation to look like y equals mx plus b. So that is, we have 3x equals 7y plus 5. So negative 7y equals negative 3x plus 5. Y equals negative 3x plus 5 divided by negative 7, which gives us negative 3 by negative 7x plus 5 by negative 7, which is 3 by 7x minus 5 by 7. So this is our equation in the slope-intercept form. So from here, we know what our m is. So m is 3 by 7. So now that we want to find a line which is perpendicular to this line, so the slope must be the negative reciprocal. So let's first do the reciprocal. That would give us 7 by 3 and a negative sign. So this is going to be our new slope. of the line which is perpendicular to 3x equals 7y plus 5. All right, so let us now find the line whose slope is negative 7 by 3 and goes through 6 comma negative 4. I'm going to use the point slope form again. It's y2 minus y1 equals m times x2 minus x1, and y minus y1 equals m times x minus x1. Plugging in our values, y1 is negative 4 and x1 is 6. We have our m as negative 7 by 3. Then you have x minus 6. Expanding it, you get y plus 4 equals negative 7 by 3x plus 14. So y equals negative 7 by 3x plus 14 minus 4. Y equals negative 7 by 3x plus 10. So this is our equation, which is the equation of a line which is perpendicular to 3x equals 7y plus 5, and it passes through 6 comma negative 4. How do we check if this is actually the equation? Is the m here, which is the slopes of both the lines, are negative reciprocals of each other, because on one side we have 3 by 7 as our slope, and for the other equation we have negative 7 by 3, which is a negative reciprocal. And one more thing is we have to check if 6 comma negative 4 is actually a part of the line, which would just mean you plug in 6 as our x value and negative 4 as the y value. So we have to plug in 6 comma negative 4. So what would you get? Y equals negative 7 by 3x plus 10. So instead of y, we have a negative 4. And here we have x as 6 divided by 3 plus 10, which gives us negative 7 times 2 plus 10. This negative 4 equals negative 14 plus 10. Have negative 4 equals negative 4. So this equation is the right equation, so it passes through the point 6 comma negative 4, and we've already shown that the slopes are correct. That is, they are both perpendicular to each other, both the lines. Yeah, and that is it for this question. And that also brings us to the end of this video, where we spoke about parallel and perpendicular lines. We first began with trying to formalize what their slopes mean if two lines are parallel or perpendicular, and then we determined, if given two equations, if we can determine if the lines are parallel, perpendicular, or neither. And then we solved two more problems where we are given a point and an equation and are asked to find a line which is parallel and then which is perpendicular. So that is it for this video. And in the next video, I'll be talking a little bit more about word problems and how these equations of lines can be used in some real world problems and how their applications work out. Okay, thank you for watching.